Okay guys, so on this worksheet, we are going to be using the quadratic formula. So let's write down the quadratic formula somewhere. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Have to memorize it. Okay, what else? It's also important to note that whenever you apply the quadratic formula, it's a good idea, after identifying a, b, and c, of course, that you rewrite your formula with parentheses. So instead of b squared, parentheses squared, instead of minus 4 times a times c times parentheses, right? All divided by 2 times a, 2 times parentheses. It's always a great idea to rewrite it with parentheses. That way you could plug in your b values, your a value, your c value, and your a value down here in parentheses. That's what I recommend. Okay, so just because this worksheet is on the quadratic formula, it doesn't mean you should jump right into it, right? For example, number 2, could you factor it? Could you factor number 2? Yes. So I would solve it by factoring. Now, it's easy because the a value is 1, so you could put x and x, and you think what times what is 7, that if you combine together is 8. 7 and 1. So let's put a positive 7 here. Well, that's an ugly 7 and an ugly plus sign. And a positive 1 here. That's ugly also. So if we were to split them and solve, set them each equal to 0, you're going to get your two answers, x equals negative 7 and x equals negative 1. So those are your two answers. Now, it is a good idea to use these easy ones to practice using the quadratic formula. So if you know that the answer is negative 7 and negative 1, it's a good idea to practice. So on a separate sheet of paper, maybe you want to plug in the a, b, and c values. Okay, so the a value is 1. If you look at your number 2, the a value is 1. So that means that you're going to put a 1 right here and a 1 right here on your a values, right? So let's put a 1 in both of those. So we're going to have 1 and 1 for the a values. The b value of number 2 was 8, so you could plug in an 8 for the b values, an 8 right here and an 8 right there. And the c value of number 2, in case you forgot right there, the c value is 7. So let's plug in a 7 for the c value. And again, for funsies, for practice, it'd be a good idea to do this and work this out. So inside your square root, that's called the radicand value. How do we do the radicand value? We simply do the correct order of operations, which is not subtraction, it's not multiplication, it's exponents first. So if I did do x squared, I'd get 64, okay? I still have the fraction, still have the plus minus, still have the minus 8 out here in front. I have a 2 on the bottom. But we need to still continue with the minus 4 times 1 times 7. I want to call it negative 4 times 1. That's negative 4 times 7. That's negative 28. So I'm going to put a simple minus 28 in here after the 64. Are you guys with me? Yay? I hope. Okay, so there's my quadratic formula. There's my work plugging in. Now let me continue working on this on the inside of the square root. What is 64 take away 28?
36.
64 take away 28. So we have the 36 in there, and that's a perfect square number. What is the square root of 36, guys? 6. Okay, let me make some space here. Hold on. So we know that the answer is 6 for the square root of 36. So let me rewrite everything up here. Let me see. Up here. So we're going to have negative 8 plus or minus 6, because the square root of 36 is 6. No more square root. It's over 2. So we end up with two different situations, one adding, one subtracting. So negative 8 plus 6 over 2 and negative 8 minus 6 over 2. So negative 8 plus 6 over 2, that's going to be a negative 2 over 2, which we know that the answer is x equals negative 1. That's one answer. And the other one's going to be negative 8 minus 6. It's negative 14 over 2. And negative 14 over 2, that's going to give us x equals negative 7. Are you with me? So we did that whole quadratic formula just for fun, just to practice, because we already knew, whoops, hold on one second. We already knew that the answer was 7 and negative 1 by factoring, or actually negative 7, negative 1, by factoring the trinomial and splitting and solving. But just for practice, we did the quadratic formula and we got those same exact answers. Okay, so maybe we should jump to one where it doesn't work out that great. How about number 10? That looks like one that doesn't work out that great. So number 10, let's say you wanted to try factoring. You first need to set it equal to 0, because remember, even if you factor, you need to be able to factor, split, and solve only if it's equal to 0. So the very first step on any one of these quadratic equations is to make sure that your equation is set equal to 0. So I'm going to add 8x, cancel. I'm going to add 8x, and I can't really add it. I'm just going to rewrite it. I'm going to have my new quadratic trinomial, 3x squared plus 8x plus minus 1 equals 0. Now you could start thinking, okay, a times c, that gives me a negative 3. What times what is negative 3? That if it combines together gives me an 8. It doesn't work. So it's not factorable. It's not factorable. Before, when I would say factor, split, and solve, give me your answers, you'd be like, I can't do it. All right? You can't do it. It could be because you can't factor it. But we can now use the quadratic formula. Okay? We could now use the quadratic formula. But notice, I can't from the beginning use the quadratic formula because I cannot identify my a, b, and c value. If you think a, b, c, wrong. The whole quadratic formula is going to be wrong. You need to first set it in standard form. Ax squared plus bx plus c. So now that it's in standard form right here, now you could say my a value is 3, my b value is positive 8, my c value is negative 1, and now you're ready for the quadratic formula, which is right there. And of course, when you use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, you need to replace the b, a, and c with parentheses. Always start by replacing the variables with parentheses on the quadratic formula. Then after that, let's plug in our b values, our a values, and our c values. So it's negative b, so that's going to be an 8 that we plug in right there for b. An 8 that we plug in right there, b squared is 8 squared. The 4 times a, the a is 3, and the c value is negative 1 over 2 times a, which a is 3. So there we have it. We are now ready to do some math here. And of course, we always start with the discriminant value, the value inside the square root, and you always do the exponent first. 8 squared is 64. So let me rewrite this thing. It's going to be a negative 8 plus or minus the square root of 64. And let's think, what is negative 4 times 3? That's negative 12. And negative 12 times negative 1 is a positive 12. So I am going to put plus 12. And then I'm going to put it over 2 times 3, which is 6. So we have that so far. Let's now continue working on the discriminant value, the 64 plus 12. So 64 plus 12 is 70, what is it, 78? 76, right? 76. So let me make some more space here. Let me rewrite everything. We're going to have negative 8 plus or minus the square root of 76 over 6. So now the question becomes, since this is not a perfect square number, right? It's not 64, it's not 81. That would be awesome if it were 81, then it would be a negative 8 plus or minus 9 because the square root of 81 is 9. But 76, there is no nice answer to it. So the question is, could you at least simplify 76? So I'm going to rewrite it over here on the side. The square root of 76, could I do anything to that? Could I break it down with multiplication to get a perfect square number? So you guys have calculators. Could you do 76, let's say divided by 4, or maybe divided by 9, or maybe divided by 16? Let's try to divide 76 by a perfect square number. If we can't do it, then we're done. We have our answer already. Let's try to do that. So I just did it on the calculator. 76 divided by 4, which is a perfect square number, is 19. So I could rewrite the 76, I could rewrite it as 4 times 19. And 19 can't be broken down any further. So I could split the 4 and the 19. That way I could actually do the square root of 4, which gives me the nice, beautiful answer 2, no more square root. But it still has a square root of 19 after the nice, beautiful 2. So what I need to do is replace the square root of 76 with the 2 square root of 19. So let's do that here. Let me replace. So I'm going to have negative 8 plus or minus 2 square root of 19 over 6. Okay? Now at this point you have 8, which is an even number, 2, which is an even number, 6, which is an even number. The variable, or the square root of 19, you pretend like if it were a variable, like an x. So all 3 terms are divisible by 2, so we might as well do that, reduce by 2. That'll cancel, that'll cancel, that'll cancel, but we're going to get new values. If you reduce 8 by 2, that'll be a 4. Don't forget that it's a negative 4. The 2, it'll cancel out completely. There's going to be no number there. If you want, you could put a 1. And the 6 is going to become a 3 if you divide it by 2. So our final answer technically is a negative 4 plus or minus. You could put a 1 square root of 19. I'm just going to put square root of 19 over 3. Ladies and gentlemen, that is your final answer in radical form. That's your final answer in radical form. That's how you're going to see it on the final exam, guys. Right? You're going to have to be able to get this answer on the final exam by using the quadratic formula. Now, let's maybe do one more. We have a couple of minutes left on this video. Number 6, am I going to jump straight into the quadratic formula? No. Why not? Because when I look at these terms, what could he do? You could pull out a 2, right? You could factor out a 2. Or because it's an equation, you can do anything you want to an equation, right? I mean, if you wanted to, you could subtract 10 here as long as you subtract 10 over here, right? So you can do anything you want to an equation. So right here, what I want to do is I want to divide everything by 2. Divide by 2, divide by 2, divide by 2, and the 0 also divided by 2. Dividing everything by 2 will give you a new quadratic equation. X squared plus 6x plus 5 equals 0. So would it be smart to use the quadratic formula here after dividing everything by 2? Heck no, it would not be smart. Why? Because the smart thing to do is to realize, hey, the a value is 1. That means I could do this. I could factor, maybe, at least try it. What times what is 5 that if you combine together is 6? Exactly. Positive 5 times positive 1. And of course, when you split them, x plus 5, if you set it equal to 0, x plus 1, set it equal to 0, you're going to get 2 answers. X equals negative 5 and x equals negative 1. Those are your 2 answers to this quadratic equation. Okay. Now let's say that you got to here and you're thinking what times what is 5, that if you combine together and you can't factor it, then right there you're going to have to forcefully use the quadratic formula. So I just want to show you the only time you really use the quadratic formula is when your equations are not factorable. Okay? Now you could always use the quadratic formula. It'll always work, right? Even from the very start, if you call this A, B, and C, you could use a quadratic formula. It's still going to give you the same answers, negative 5 and negative 1. So if you want to practice, go for it. This homework is meant for you to practice the quadratic formula. So it might be a good idea to do the quadratic formula on all of them. But if you want to factor, split, and solve, go for it. But there's some of them that you have to use the quadratic formula, like number 10. I hope this helps.